We'll get started today. Welcome to ISTC. I think many of you have been here before, but if not, my name's Nancy Holm. I'm the sponsored research coordinator here and the seminar series organizer. You may have picked one of these up. The gold sheet has our entire seminar series listed on that, and there's also a sign-in sheet if you could sign in so we can keep track of how many people are attending our seminars. So today we're very pleased to have with us as our speaker Dr. Jim Hoff. Dr. Hoff is an experienced executive and researcher in the buildings material industry, retiring as Vice President of Technology for Firestone Building Products in 2007 after 23 years of service there. Dr. Hoff currently serves as the Research Director for the Center for Environmental Innovation in Roofing in Washington, D.C., and is President of Technos Research Incorporated, a consulting organization dedicated to expanding understanding of the building envelope. Dr. Hoff holds his undergraduate degrees in psychology and architectural design, as well as a master's and doctorate in management, and he's published numerous articles on building system performance, quality management, and life cycle analysis. Today he'll be speaking on the topic of life cycle assessment in the building envelope. Please welcome Dr. Hoff.
Thank you very much. Thank you very much. First, perhaps I probably better give you some background. I'm not a peer researcher. I'm much more of a practitioner and a consultant in the building envelope arena. I guess somewhere along the line, a couple of papers I have written on life cycle assessment sort of got attention somewhere. But most of my work in life cycle assessment has been in two areas. One is trying to serve as a bridge between private industry and the life cycle assessment academic community. And most of that is to try to bring industry, both industry researchers and practitioners up to speed about what life cycle assessment is, what it can mean, and what the mechanics of life cycle assessment are. And in particular in the building envelope area. The second area is that I have also been a representative of a number of organizations in industry as those organizations try to interact with both the life cycle assessment community and the building codes, standards, voluntary standards community in the integration of life cycle assessment into various building codes and other standards and documents that deal especially with life cycle assessment and the building envelope. What I'd like to share with you today are some of the experiences that I've seen and also share some at least things that I've sort of discovered through the experience over the last couple of years. The first is a topic addressing the relationship, especially in buildings, between life cycle assessment and durability. In some ways, I sort of see durability as the elephant in the LCA room in building assessment. Durability is a key determinant, and it's important that we have good definitions of what durability means and what the consequences of those definitions mean to the kinds of assessment systems we build. The second issue, being involved with industry associations, I've done quite a bit of work on product LCA as those industries work to develop standards, product category rules, environmental statements, whether they're EPDs or other kinds. And I think there's an important discussion to be had about the challenges of sort of what's evolving sort of a two-tiered system of LCA, looking at whole systems with LCA, but also having this fundamental underpinning of various products and components in those systems that also have to be studied. A little bit of discussion about applying LCA, and especially at the end, some discussion about, at least from my experience, and having represented industry in a lot of building code hearings and in other areas, just a little bit of background as to where LCA is today being utilized in building codes and standards. I really believe, and it's been I think it's my experience in the roofing industry. In the role I had in private industry before I started consulting, I was the chief technology, chief research, and technical officer for a fairly large organization, actually the leading supplier of roofing materials in the United States, Firestone Building Products. And in that role, over I think about a 15-year period while I had a specific role in that area, my name was on the warranties that Firestone issued for all of their roofing systems. For better or for worse, that name now is on, I think, 3 billion square feet of roofing warranties. So I had a real opportunity to be right on the firing line of what durability and service life issues can happen. And I have, I guess because of that, I have always felt that there are issues in durability that may not be effectively addressed in a number of voluntary green building programs today. And I guess I express a bit of concern about that. And that's because service life, certainly, I believe, if you do a sensitivity analysis in buildings, and I'll be, as I said, speaking mainly about the built environment, if you do a sensitivity analysis of variables in LCA, I think you'll find that service life in buildings will be the most sensitive variable in the analysis. And that's simply because of the reasons that service life in buildings can vary anywhere from 20 years to 60 years to 80 years, 100 years. And that variable in service life, I think, has a much larger impact than other specific variables. And I really think that durability, then, is probably one of the most sensitive service life predictors. Now, it depends how you define durability. But I believe that if you have a proper definition of durability, it becomes the key predictor for service life. A definition that I like comes from not an American standard, but a Canadian standard on guideline for durability in buildings. And the definition in that standard is the ability of a building or any of its components to perform its required functions in its service environment over a period of time without unforeseen cost for maintenance or repair. I think this is an excellent definition because I think many times definitions of durability talk about function. They clearly identify that a component, a material has to perform a defined function. And it has to define it for a period of time. In buildings, we certainly have to talk about the performance of that function in a specific environment. The part I really like about this definition, though, is that last phrase, without unforeseen costs for maintenance or repair. It is almost the assumption, then, is this definition means that there must be an assumption for maintenance and repair. It isn't so. In other words, durability then is a multivariate factor of a combination of looking at initial durability characteristics and then also developing an organizational plan as to how those durability characteristics can be either maintained, repaired, replaced as time goes on. And I think that's an important definition, and a definition that then means that I think this has a significant effect for life cycle assessment, because it means that in life cycle assessment strategies for buildings in the built environment, when one looks at a complex system like a building, there's going to be a need to take a look at the potential trade-offs between various initial levels of durability and a plan, an organized plan for maintenance. And that's why I think that why those all sort of fit together. And the problem that I see, and again, is another Canadian, a Canadian architect, who I think sort of defined the problem very well for me. He said the majority of green building assessment systems focus on the design of the constructed building, with little focus on the effect of the building system's life during operation. this tendency has resulted in the failure of many rating systems to properly consider durability, life cycle cost, and the effects of premature building envelope failures. And I guess because I work so much in the building envelope, and especially in the roofing area, I'm keenly aware of the relationship between the durability, service life, performance of roofs on buildings, and the long-term durability service life of the building itself. Buildings tend to fail after the roof fails first. The roof tends to be the first thing that goes, and that's because moisture can have so many effects within a building when it's not controlled properly. And that means that really, if you look at building durability and service life in terms of life cycle assessment, you can typically have a building, an all too common building life cycle where you have initial impact, certainly, of all the raw materials acquisition, transport to the site, all the manufacturing involved, the installation and so forth. Very high impacts to start with. Those impacts, at least the embodied impacts then, of course, are relatively low during the actual use phase. There's additional impacts at the end of life, whether that's the impacts related with demolition, removal, some degree of recycling if possible. But if that use phase is small, you can see then you're back in the same cycle again. You're doing the same thing. And you may be, you can have, if you have challenges in durability, you're reducing service life, that's accelerating the replacement cycle, and that means you have both increased environmental and financial impacts. While a really sustainable building life cycle is a life cycle for a structure that may have about the same impacts, embodied impacts to begin with, may even have a little bit more, perhaps. But that those impacts combined with a maintenance plan for a facility can extend the use phase. And then there's an opportunity even beyond that planned maintenance for planned interventions of significant renovation and repair that can further extend that use. And certainly, if you look at just the impact as being the area under the little curves I have here, it's very clear that, it's very clear that the impact overall is significantly reduced. Not only reduced in total, but also reduced as a unit of impact over the life of the facility. And that means there's some key durability issues when you look at a building and try to assess life cycle impacts for a building or a facility. And the first is this concept of balancing initial durability with planned maintenance. That really means there aren't any really good answers. I run into this all the time with my clients in the roofing business. I want a good roof. What's a good roof? And it depends. It depends what your functions are, but it also depends on what your resources are to be able to interact with that roof over a period of time. It's very possible. In fact, I've seen many times that what some professional roof consultants might consider to be a rather poor roof can actually perform pretty well if it's being maintained properly. So many times, those are key decisions that need to be made because those decisions then have a significant impact on long-term environmental impacts on the structure. Certainly, looking at the validity of maintenance assumptions, and that sort of plays back into the balancing of durability and maintenance. I'm not trying to say that every facility should plan to have a very aggressive maintenance program. As a professional designer ought to be looking at the trade-off between higher levels of durability or redundancy in systems and then balancing that with the ability of the building owner, building manager to both plan and conduct necessary maintenance. Third, modeling and prediction of aging effects. I think one of the biggest challenges within life cycle assessment and sustainable buildings today is that we're sort of innovating as we go, and we have to try to develop systems and programs that can allow us to try to model and start to predict what the aging effects of new structures. What are the aging effects when we start using new materials, especially materials where we're substituting bio-based polymers for petroleum-based polymers, where we're increasing levels of recycled content in materials. We need to have a better understanding of predicting those aging effects, and also looking for possible interaction effects. Once we have new or changed materials, we also need to look at what the potential is for interaction between those materials in a structure, in a building system. When I talking about, I mentioned the product and system LCA. There are certainly challenges in applying life cycle assessment to buildings. I think the biggest challenge today is the area of product and system LCA. And this is really more from a practitioner standpoint. The life cycle assessment community is strongly focusing on a system-based approach to LCA, and that's very understandable. The community is really concerned that bad decisions can be made just looking at life cycle assessment of individual products. At the same time, the life cycle assessment community would like to have very robust system LCAs based on equally robust life cycle inventories, which requires extensive product LCA. And I think there's a real challenge right now within the building industry developing in the development of adequate database to support decision making in system LCA. And certainly there are, I think, beyond the issue of product and system LCA, there's some significant challenges in application of LCA. First, there's a challenge of resources. Just in the small area of the building envelope that I work in, I have worked with 2 organizations in developing initial LCAs for products, generic approaches to life cycle assessment. Each of those products represents probably less than 1% of the total number of products that go into a building, and yet the cost of those life cycle assessments was in the hundreds of thousands of dollars to do it correctly. And I'm really concerned that I just don't know if we have the resources, if the resources are truly available to develop the robust kind of database we have, especially since most of that database is going to be funded by private industry. And so I do know at this time that plays into sort of challenges of awareness and knowledge and resources in private industry. There are some leaders in the building community that have sort of embraced life cycle assessment and are certainly moving pretty quickly to develop the kind of data that's necessary for effective life cycle assessment of buildings. But the great majority of building materials suppliers, very frankly, are having a hard time even spelling LCA right now. And it really is a challenge. How to have companies develop, to invest money in LCA, especially in generic LCAs that feed good systematic approaches to LCA, but also knowing there's going to be a tremendous demand for proprietary LCAs, and I think there's going to be a challenge there as well. Again, from my experience in private industry, I know that any time that I was ever involved in a project that somehow measured the performance of a product that my company was selling, no one really people were less concerned in the measurement than they were, well, how does that compare to the other guy? In other words, information measurement is a leverageable marketing commodity. And the challenge we're going to have is, as companies develop proprietary LCAs, I think that there's going to be a real tendency to I won't say it's to distort the LCA, but there'll be a real tendency to apply the LCA in ways that that'll make it very difficult for architects, engineers to really utilize that data effectively. So there really are challenges today in awareness and knowledge. I see this very plainly. The real challenge in the construction industry that I see when it comes to sustainability and life cycle assessment. I've worked in a traditional industry providing fairly basic building materials for most of my career. But I did have the fortune of being with a company that was acquired by a Japanese parent, Bridgestone Corporation, in 1987. And because of that, I got to learn quite a bit about quality management, TQM, ISO 9000, and our particular company was a leader in developing, in obtaining, instituting quality programs and obtaining quality certifications for our operations. When I started hearing more about sustainability and understanding sustainable concepts, it was very easy for me to see, well, gee, a lot of the concepts in sustainability are the same kind of process-based concepts that ISO 9000 focuses on. And I can remember going to meetings in the construction industry and saying, you want to understand what this green stuff is. Sustainability, it's ISO 14000, and it's really just the sustainability management version of quality management, ISO 9000. I thought that explained it very well. The problem was that no one in the construction industry knows what the heck ISO 9000 is. And so working with an industry that does not understand, has not embraced process-based solutions to quality. It's probably the biggest challenge I see within this area because life cycle assessment is a process-based tool. It's a process-based tool that allows the evaluation of options. It's a process-based tool that allows a measurement of continuous improvement or progress. But it isn't necessarily a very good score sheet, and it's also doesn't serve very well as a prescriptive, developing a prescriptive standard from the results that you obtain. So I hope that, I know some of those, I hope I'm not rambling too much about some of those experiences, but again, this is just sort of the same thing that we certainly want to develop meaningful generic data from proprietary sources. The only way we can develop generic data, very frankly, is to develop it from proprietary sources, especially in building materials. There are very few generic building materials. Even concrete today has such a level of fragmentation in terms of different approaches to concrete and so forth, that the only way to obtain generic data to make decisions is to really utilize those proprietary sources. First, they're going to be very difficult to obtain. First challenge I've always had working with building materials organizations is, getting the members to even release some of that data. That's a challenge in the first place. And certainly, and also then this is highly variable data. And then trying to normalize data from slightly different processes, slightly different materials, slightly different plants to try to come up with something. I'm not even sure that when you finally do take all that high variability together that you may have something that looks akin to a generic approach to a particular building material. But the variability is going to be very high, and I'm really not sure that when you try to normalize that you're really developing anything of real significance and usefulness. And on the proprietary side, there's a real challenge developing a uniform playing field for proprietary data. There are very limited product category rules available in the United States for developing life cycle assessment. Some industries are starting to work on that, but we've got a long, long way to go. And that means that as pressure increases on industry and on building practitioners to start using LCA, I think there's going to be a tremendous potential. There's going to be a tremendous challenge in terms of trying to find uniformity, and there's going to be a lot of conflicting claims and so forth coming out. I think, when I look also at product LCA, it's necessary. I certainly agree with many LCA practitioners that decisions shouldn't be made comparing different life cycle assessments of particular products unless you're looking at the systems. And that also means that product LCAs, especially in buildings, tend to overemphasize the embodied impacts of a material. A study done at Oak Ridge National Laboratories suggests that of the total impact of a building, environmental impact, energy and environmental impact over time, over about a 30-year period, about 20% of the impacts will be initial embodied impacts, 80% of the impacts will be operating impacts, mostly operating energy, but that means many times, and many building materials have a significant impact on what levels of operating energy could be in a structure. Second, in product LCA is the issue of order of magnitude. The first LCA I worked on was an LCA for a rubber roofing trade association, and we did a complete workup using the Tracy model of all the different environmental impacts. And the real issue was if one form of our material had 35 units of one of the Tracy impact characteristics, and another had 34, what did that mean? Was taking the order of magnitude within those impacts is very difficult to judge, let alone even try to start weighting those impacts. But I think there is a real challenge and I think it will be a tendency for many people in the design community to start requiring environmental statements, start comparing those statements, and possibly make decisions that really neglect either operating impacts of products, or really are making judgments based on something where the order of magnitude is not significant. And of course, then all the issues of out-of-boundary features and benefits and all the potential for systemic interactions. At the same time, system LCA challenges probably the other side of it, a potential overemphasis on operational impacts. And as I mentioned before, this chicken and the egg challenge. How will LCA professionals obtain the product LCAs to build robust databases while at the same time trying to de-emphasize the importance of the functional importance of product LCA? And certainly real challenges with end-user knowledge and lack of tools in this area. In the same way, in terms of applying all the issues of categories and scales, I can tell you that the more that I've looked at this and worked with a couple of associations, I'm working with a roofing association that mentioned in Washington, that as we tried to develop a sustainable assessment tool for roofing systems, we started to look at trying to develop a weighting system for all of the environmental and energy variables we had. And it became so complex that we felt that we were better off, at least at this point in time, not trying to even wrestle with the weighting system, especially trying to provide something meaningful to end users, And we tried to use more of a balanced scorecard approach. So we ended up more with an approach that says there are key environmental categories, there are key impacts. We're not going to try to figure out what exactly the weight is of a gallon of water saved versus a BTU of energy saved. But we are going to at least say these are broad categories. They are all meaningful, and a meaningful design utilizing this assessment tool would require that you have a balanced approach and a very balanced scorecard for those attributes. I mentioned applying LCA. The standards today, we have a long, long way to go. ASTM has taken the first step by developing a separate committee now for sustainability, E60. But it's going to take a while, and especially in the area of development of category rules, broad functional category rules for all sorts of building materials. The databases, I guess from my standpoint as a practitioner working with designers, I don't understand how today, say, the LEED Green Building System can talk about systematic LCA for buildings. There is no data. You have to make up so much or make so many assumptions that there just isn't a solid database, especially in the United States. The U.S. LCI database is so small, so underfunded, so disorganized that that we really are depending upon a database in Canada, the Athena Institute, and much of the data in the Athena Institute is just so poor in terms of the initial inputs. It's very difficult to use. I ran into that when I was working with the Rubber Roofing Association. I went back into the original studies that were used by the Athena Institute to develop LCA for roofing systems in their systems or their building systems component calculator. And the entire formulation for one of the major products used in roofing was based on an interview with a guy I had hired about 5 years before as a sales rep. He's a very nice guy, but I'm not sure he really knows that much about the formulation of products. And the level of assumption was just it was almost laughable that it was so inaccurate. But that was a challenge. They had, the Athena Institute wanted to get things going. They hired an organization called Franklin Associates, very good group. And I'll tell you, I think they did as good a job as anyone could have done for about $40,000 to develop this. And this was a very comprehensive study of all sorts of roofing materials. I couldn't have done any better for that, but that's the real challenge. So I think that then the challenges of funding are going to be very significant. And at the same time, we've got this train moving forward where there will be very, very elaborate credits within the next version of LEED for buildings that will contain elements of LCA. And I don't know where the material is going to come from to be able to meet those requirements. And codes and standards, and when I say LEED, I assume some of you are involved in the built environment, familiar with LEED. I would like to ask, have you seen the latest draft of LEED for buildings? Well, I can tell you this: it takes up a little more space on your computer than the last version did. The current draft of LEED 2012, that just was released. Released July 31st with comments due. I think today. This is the 14th. 5th. Too late. Sorry. Due 45 days after a release in the middle of summer. The current LEED document, LEED version 2 or LEED 2009, is 110 pages long with the introduction. Draft 2, without an introduction yet, without all the formatting in its bare bones, 220 pages. New credits. This will be it'll be interesting to see how this is received by the design community, because it has lots of things in it. They're trying to take off a pretty big bite, but it's very difficult to organize. But there is a new credit for whole building LCA versus a reference building that is yet to be determined. And there's a new credit for products with EPDs. So I think there will be some stimulus there. But again, that credit still doesn't exactly describe how those EPDs will be used in design. And I guess you could collect them. I'm sorry, an environmental product declaration, and I'm very sorry. I'm sorry about that. An environmental the method of reporting an LCA for a particular product in accordance with one of the ISO 14000 standards. I apologize, I'm not explaining that well. There will be a final hearing for a new code called the International Green Construction Code. There is an option for whole building LCA, but it's going to be compared between utilizing a whole building LCA or having a laundry list of preferred products. And that's something else I've seen within this area, that because LCA is still very confusing to many people, there are tendencies to default back to what I would call laundry lists. And in fact, the new version of LEED does the same thing. They just dump all sorts of desirable characteristics of materials into a single category, and then it just says, pick one of these, and if you meet 50% of the building components, then you get the credit. And it could be a combination of bio-based, recycled, reused, renewable materials. And another credit, by the way, if you didn't know, and this one I can see different approaches on it. LEED had taken a lot of criticism over the use of the regional materials credit. Originally, there was a credit for materials that were produced within a 500-mile area. I couldn't believe they could actually try to make it worse, but they really did. They first of all, they did finally admit that the regional materials credit really has very little to do with the environment. That regional materials credits, especially the regional materials credits that still allow for portions of the materials to come from outside the region as long as they're finally assembled, they just flat out said, okay, it has nothing to do with the environment. It has to do with a new concept in LEED called support the local economy. And I'll tell you, it's interesting, at least they're being straight up about it. And now they call the local economy the metropolitan statistical area or equivalent where the project is being installed. So that would mean Champaign-Urbana is a metropolitan statistical area, so there would be preference given to products produced in Champaign-Urbana. I can tell you on the roofing side that there are going to be hundreds and hundreds of people, if that takes off, they're going to be mixing up cans of stuff in their garage. I've got the locally sustainable roofing material here, or paint, or whatever. It could be it could be interesting. In terms of ISO standards, some U.S. companies have started to develop true third-party product environmental, third-party certified product environmental product declarations, but very few. There are many more sort of non-certified product declarations that don't give you all the information you really need. And some U.S. trade associations are now starting to develop what are called product category rules, but that progress there is still very slow as well. And these are vitally necessary. Without those, you really can never build a meaningful database that you can relate data with each other. I mentioned that a new committee is formed at ASTM, Committee E60, to address LCA, other sustainability standards. And there are now, I think you'll see a proliferation of ANSI standards in the area of sustainability. everyone wants to get in the game of grading and evaluating and scoring products so they can give them awards and certifications. UL, and I'm sure you probably certainly may be familiar with UL in its area of certification for fire and safety. UL has acquired a couple of green labeling companies and have set up a separate organization called UL Environment. And they are currently developing what I would again call laundry list approaches to green product certification. So I think the real challenge for for utilizing LCA in built environment, you have a challenge of resources today, but you also have this challenge of a lot of noise that's going to be generated through all of these other approaches that are probably very simplistic, certainly have no weighting, but you can put together a committee and get a laundry list, and you get so many. And I also noticed that the UL standards also for the first time for UL will have levels within the standard of silver and gold and platinum levels of achievement in those standards. It just I don't know, just from a fellow who used to work with fire ratings at UL, this is like, this is something different. I never thought, certainly, I'm not sure I would really want to have fire ratings as an example that were, gold or silver or platinum fire ratings or something. I think it tells you a little bit about the challenge of even trying to quantify what these benefits are. So I hope that I hope that was helpful for somebody. Again, I apologize. I'm much more of a practitioner. And I don't know what all of you are working on or involved in life cycle assessment, but I hope that does give you at least a broad overview of what's happening at the practitioner level there.
Thank you very much.
Yes, absolutely. Yes.
Well, you made the argument that this is just going to cause a great deal of confusion in its present state. So if you could wave the magic wand, what kind of system would you like to see developed?
I think that I guess I have to say that I'm sufficiently confused now that I'm really not sure. I'm not sure what will develop. I guess that I think first that I really believe that the biggest challenge I see is that the academic community is moving much, much faster than the public is in this. And I don't think that the public has quite understood the level of complexity. I'm not sure how a lot of progress can be made until there's a much higher level of public awareness about what environmental impact really means. I think we're probably going to go through a period where there could be an enormous amount of confusion until there's a much higher level of public understanding, public awareness. I'm sorry if I'm popping out of hand, but I'm not sure there is I haven't been able, at least myself, to come up with something like that.
Current vote of green roofs and those types of things, where do they fit into this life cycle analysis? Has there been much work done on the impact of that on life cycles?
Well, I'd say that green roofing, I think, is a very good example of. And I said by green roofing, we're talking about vegetated
Plants.
Plants on, yes. And I think. I'll have to. I guess to tell you a little bit about where I think that sort of stands in the United States today. I could go back to another time in the history of the roofing industry that may be sort of a predictor. in the late 1970s, during the Arab oil embargo and the energy crisis that we, as a country, we faced at that time, that energy embargo had a significant impact on the roofing industry. All of a sudden, not only did the price and availability of hot asphalt, traditional asphalt roofs, go up, and there were shortages, but the quality of that material changed dramatically, and that was because refineries, by pure economic process, found better ways to get more gasoline out of every barrel of oil and leave less and less useful materials behind it in asphalt. When we were facing that crisis, we saw an introduction of a lot of new roofing systems in the United States. And they were, but I say new, they were only new to us. Most of the roofing systems were developed in Europe, whether they were thermoplastic roofing systems or roofing systems that combine some thermoplastics with higher grades of asphalt for just maybe one layer instead of 3 or 4 layers. But these were all technologies developed in Europe. And they were all technologies that were proven in Europe, all technologies that worked well in Europe. And then they came to the United States, and we went through a good decade of terror in the roofing industry. It was awful. It really was to develop, because one, we may have a different approach to construction trades and workmanship in this country, but also we have a much more diverse nation in terms of climate. So when products were proven to work in Germany, didn't necessarily mean they'd work in Alaska or work in Arizona or wherever. And we had much higher climate extremes. Garden roofs were developed in Europe. Everything we know about the technology of garden roofs comes from Europe. And once again, they've assured us that this is the right thing to do, without really looking at some of the fundamental issues of durability and system management for a different workforce and for significantly different climatic conditions. And also, I also should mention different approaches to building structures. European roofs, there's a much higher preponderance of concrete buildings in Europe, concrete decks. In most of the buildings, I would imagine I think 85% of all commercial buildings in the United States have metal decks. And I don't have any of you ever walked on a roof with a metal deck? You can feel it. It's not substantial. And there's a level of deflection and so forth that can be a challenge. So we have levels of movement. So I think there are some challenges. The other challenge with vegetated roofing is certainly provides certain benefits, but the costs are very significant. I'm not sure that vegetated roofing in and of itself is much more than will ever be much more than a relatively niche product in the market. The leading proponent of green roofs in North America is an organization called Green Roofs for Healthy Cities. And 2 years ago, Green Roofs for Healthy Cities announced in their annual survey that in 2008, there were over 10 billion square feet of green roofs installed in North America. And that's it. Sounds like a sizable number until you recognize that, 10 million square feet installed. But during that same time in North America, there were about 4 billion square feet of roofs installed. So the level of share is still relatively small. And I'd also say that there easily could be other approaches that can provide some of the same benefits, not all the same benefits, but if we're looking at water retention systems, there are other ways to do that. If we're looking at ways to cool our cities, there are other ways to do that other than vegetated roofing. And I think that vegetative roofing is going to be very difficult to justify the levels of cost associated with vegetative roofing, other than for highly specialized applications.
I'd like to sort of ask the same question in a different way that was just asked here to my left. What do you see in the future? You seem to be expressing a lot of frustration at where standardization and information gathering to improve this as a consumer product. Some frustration at where we stand with that. And the two standards that you spoke a lot about standards, but you began with Canadian standards for durability. We've done the same. It's the only place to go. ISO for quality. We don't have the same equivalent standards here. The prospects for improving the standards, the standards are getting more complex, more uneven. What's the future for standards here? And I ask that because in ASHRAE, we just had a seminar on the question, should we have a standard for building envelopes? And there were those who argued yes, particularly those within the industry, because selling to the public requires a public announcement of what you are, what you have, and this can only be done in a smart way if there's the playing field of standards. But on the other hand, it's almost like we throw up our hands and say, we've taken this maybe as far as we can. Politically, it's hard to sell. The money isn't there. The political clout isn't there. You're aware that today or yesterday or this morning in the House of Representatives, they've taken out all the compact fluorescents and put in incandescents because there was one representative who apparently felt that was a better thing to do, which led to a whole lot of jokes about how many representatives. But what do you see in the future for standards? Do we just have to keep saying there's guidance elsewhere in the world for what we could do better here in the U.S., or are there other paths?
The first thing I think the first step is to, and one thing I constantly do, especially in traditional industries like roofing, is to emphasize that there are many more approaches to standardization than perhaps we have tended to focus on. You're involved in a lot in the building industry and standards, and a lot of arguments for standards appear to be sort of a polarized prescriptive versus performance approaches. I would say there's a third way, and that's a process-based approach. And the more that as a society we would understand what process-based approaches really mean, and the more that we understand that perhaps our answer now is not a standard but a standard process to arrive at a good outcome. And so I hope that at least that there can be more approaches that way. They are challenging. They're not as black and white as prescriptive standards. But I would say that in the long run, when you're dealing with complexity, you might as well then combine a method of dealing. First, you need a standardized method of dealing with complexity, and a methodology that can be utilized, but utilized pretty much on a case-by-case basis by expert practitioners. I hope that we move to that. I think that's one. I think that's one area where I am concerned that the lessons that many people in our society learned during the quality revolution of the 80s are being lost very quickly, or at least they are being held very closely within. That's for a factory. It doesn't apply to other issues. I've seen that in buildings as well. The construction industry has been so slow to develop anything in the way of the only process-based standard in the construction industry is the punch list. That's as good as it gets. But I hope that helps a little bit. But I really think that looking the more that we can develop standard processes instead of just a standard, I think the better off we'll be.